we're going to talk about congruency versus similarity. All right, if they're congruent, what must be the case? All the sides have to be equal and all the angles have to be equal. If they're similar, what's the case? All the sides are proportional, meaning they have the same ratio or the same fraction value or the same scale factor. But the angles would all have to be congruent also. Okay, so we're going to talk about congruency versus similarity with some different figures like will be on the test. So this first one, these two figures right here, are they similar or are they congruent? Well, you can obviously tell that the side lengths are exactly the same. So therefore you have side, side, side congruency from the triangles. So if you have side, side, side congruency, the triangles must be congruent. So these are congruent. Okay. They are also similar, but they are congruent because each side length is exactly the same. Also, another way to check this is take the side length to short length, and create a ratio. 3 to 3 will reduce to 1. 4 to 4 reduces to 1. 5 to 5 reduces to 1. So every time you set up that ratio, if they all reduce to 1, that means they're going to be congruent. That's another way to tell that they're congruent versus just similar. Now we're going to move on to the next one. These are two circles. Okay, so this circle has a radius of 1. This circle has a radius of 4. Are they congruent? Obviously not, because the radiuses would have to be exactly the same for them to be congruent. However, are they similar? Well, here we're trying to look for angles and there's no angles, and you're like, I don't know if they're similar because I don't know about the angles. But think about a circle in general. Would all circles be similar, no matter what the radius is? So think about that. What would the ratio of their radii be? So if I was going from here to here, it's going to be 1 to 4. Or if you're going from here to here, it's 4 to 1. But either way, that ratio, 1 to 4, would be the same whether I drew the radius here. That radius is still 1. If I draw the radius over here, that radius is still 4. No matter where I were to draw those radii in those circles, my ratio of the radii would be 1 to 4. Or going this way, 4 to 1. But the ratio will not change. So therefore, these are similar. But they are not congruent. The reason they're not congruent is because these would have to be exactly the same, or they'd have to reduce. 1 divided by 4 would have to be 1, which it obviously isn't. Okay, let's move over here. Are these similar or congruent? Well, we know this is a rectangle, so all the angles are congruent. And all the angles in this square are congruent. So a lot of people would say, well, because all the angles are congruent, they're congruent. Don't make that mistake. The angles aren't the only thing you have to check for congruency and similarity. You have to make sure that the side lengths are also proportional. So if this is a square with side lengths of 4, this is 4, this is 4, this is 4. If this is a rectangle with side lengths of 4 and 8, this is 8 and this is 4. Are these figures similar? Well, a lot of kids would say yes because of the angles, like I mentioned. They're wrong. The reason is that if you look at the corresponding sides, these sides, 4 to 4, would give you a ratio of 1. But these sides, 4 to 8, would give you a ratio of 1/2. If they are truly similar, all side lengths would have to have the same ratio. So therefore, because this one has a ratio of 1, and this one has a ratio of 1/2, they are not similar nor congruent. So not similar nor congruent. Okay? All right, let's move over here. Here we have two similar figures. It's going to tell you in the problem, hey, these two figures are similar. Find the following lengths or angle measures. So I'm told already these are similar. Does that mean they're exactly the same? Does that mean they're congruent like I talked about over here? No, these are not congruent, but they are similar. So the ratios of the corresponding sides should be the same. So what I'm going to start with is the shortest side of each triangle as I'm finding it. Well, let's start with the angles. So first of all, let's start with the angles because this asks for the measure of angle x. So I'm looking at this x and I'm trying to figure out what corresponds to it. Does B correspond to it? Does A correspond to it? Or does C correspond to it? It says the figures are drawn to scale, which means that their angles should be corresponding. So if you think about this, Which is the biggest angle in this top triangle? Don't even look at this. Just look up here. Which one is the biggest in this top triangle of those three angles? Well, it would be this one, A, right? Now look down in this triangle. Which one is the biggest of these three triangles? Well, it would obviously be Y. So therefore, A and Y, if they're similar, must be the same measure. So therefore, Y is 91. So I can put that right here. Hey, that's 91. Now looking at X and Z, which one is bigger? Look at X and look at Z, which one is bigger? X is a little bigger than Z. Now look up here. Look at B and C. Which one of those two is bigger? B and C, which one's bigger? Well, obviously C is bigger. So C must correspond to X. C has to correspond to X. Therefore, X must be 49. I'm going to put a 49 in there. Now, a lot of kids are like, well, they don't give me B, so how am I supposed to know Z? Well, you have to remember that all the angles of any triangle add up to what value? 180. So I'm going to take 91 plus 49, add those together. That's going to give you 140, I believe. Is that right? Okay, and then I'm going to subtract that from 180. So 180 minus 140, that's pretty easy. That's going to be 40. So these two angles each have to be 40. Okay? This little trick of having 180 degrees be the measure of any triangle is going to be important on this assignment, okay, on this test. You need to know that. Okay, if it's a quadrilateral, if it has four sides and four angles, those must add up to 360. Those are some things you're going to need to remember no matter what. Now let's talk about the side lengths. Okay, the side lengths are not exactly the same because they're not congruent, but they do correspond with the same ratio. So look at these two figures again. What is the smallest side of this triangle? Well, it gives me 6, 8.1, and 10.2. So obviously 6 is the smallest side. So now I'm going to look at this picture. I'm going to say, all right, if that's 6 and this is 5, this is the smallest side of this triangle. So I set up my ratio 6 to 5, going from the top to the bottom. Top to bottom. I like to write these out to the side so I remember which triangles I'm talking about. The 6 came from the top triangle, the 5 came from the bottom triangle. If you'll make that distinction, you won't mess up your ratios as you go to write them. Now I'm going to say, okay, this equals, now let's go to the next biggest. What's the next biggest? Well, up here, the next biggest is 8.1. Now, in this one, what's the next biggest? Is it YZ or XZ? Well, obviously, this one is YZ. Okay, that's the next biggest. Okay, so now I'm going to cross multiply. So I'm going to cross multiply 6YZ equals 5 times 8.1, which is 40.5. Okay, 5 times 8.1, I cross multiplied there, and then 6 times YZ, I cross multiplied there. Now, how do I get the YZ by itself? It's got 6 times YZ, so I've got to do the opposite of timesing, which is divide. Oh, sorry, by 6. So I'm going to divide by 6, both sides. Now I have YZ equals 40.5 divided by 6. That's 6 point something.
7.5.
6.75 is my length. So that's going to go here. Okay. Again, YZ corresponded to AB. Notice that the top to the bottom, these two were corresponding sides. Same thing is going to happen as I set up my equation to solve for YX. I'm still going to use 6 over 5, small side to small side, over, so you can think about that as these being the smalls. And now these are the bigs. These were the mediums, right? So I'm going to go smalls to bigs. So thinking about the top big side, 10.1, or 10.2, sorry, over, and then this side, I don't know. I'm going to call it Y. I called the last one X. So I'm going to call this, oh, I guess I called it YZ. So I can call this XZ. It's fine. So let's call that one XZ, okay? And we don't have to mess up with the Y. So X to Z corresponds with B to C. Big side to big side, top triangle to bottom triangle. Now I just cross multiply again. So I get 6XZ equals 10.2 times 5, which is 51. Now I'm going to divide by 6, and XZ equals 51 divided by 6.
45.
What? Divide. 51 divided by 6.
8.5.
8.5. She subtracted when we should have divided, but that happens. Okay, so that's going to be my answer there is 8.5. Okay? So again, key thing here, corresponding sides, smalls to smalls, bigs to bigs, mediums to mediums. Okay? That's important that you put corresponding sides over each other, and then you pay attention to which triangle is representing the top. Top triangle here goes with top here. Bottom triangle here goes with bottom here. Could I have reversed that? Sure, it doesn't matter. I just would have had to keep track as I wrote it here. That way the cross multiplying would have happened correctly. Okay? Let's move to the next one. So now we have this same situation over here. This one's a little tricky in how it was written and drawn. But again, if you'll pay attention to small sides, big sides, longer sides, you could solve any of these sides. Okay? So what's the equation I want to set up for x? Okay? So again, I'm going to think top triangle, the bigger one that's on top, over bottom triangle. I like doing top to bottom when possible because obviously you're having the top of an equation over the bottom of an equation. It makes it easier to do the ratio. And it's easy to keep track. So now I'm going to say, okay, I want to solve for x. So I'm going to say the top triangle x corresponds to what side? Now this is kind of tricky. Should I do x over 2 or should I do x over 5? Which side corresponds? This is hard to tell. What you need to look at is at the angles. Notice that the right angle is here in the top triangle, and the right angle is here in the bottom triangle. So where is x compared to that right angle? Obviously the x is straight across from the right angle. So what side corresponds to that x in the bottom triangle? Obviously it's going to be the 5. So I need to write x over 5. The way kids are going to miss that is they're going to write x over 2. Do not do that. Make sure you have corresponding sides. If the x is opposite the right angle, then I have to use the side opposite the right angle in the other triangle, which would be 5. So it has to be x over 5. Do not write x over 2. That's where you'll miss it. Okay? So I'm going to write x over 5 equals, now I'm still going top, 4.2. Notice that came out of the top triangle. It corresponds, it's a leg next to that right angle, and the corresponding leg in this right triangle that is the shortest leg, notice. This is the shortest leg. This is the shortest leg, notice. So I'm going to go short. So if you want to think that, short to short. This was actually a hypotenuse because it was opposite the right angle over the hypotenuse. So again, corresponding sides are congruent to each other. Now again, I just cross multiply and solve. So I'm going to do 2x equals 4.2 times 5. Now I didn't even multiply this out because I know I'm going to divide by 2. And because I don't have a calculator just handy with me, I know I can take half of 4.2. Half of 4.2 is 2.1. 2.1 times 5 is 10.5. That way I didn't have to use a calculator. But if you have a calculator, you can just use a calculator and do it. So it'll work out. All right? Okay, you're going to have a story problem on there. Easy story problem. We went outside and measured some of these when we were doing these. We have a tree. It's going to cast a 20-foot shadow. So the shadow of the tree, so here's the tree. I'm really good at drawing trees. I'm an excellent tree drawer. So there we go. Okay, so there's the tree. Here's the shadow of the tree down here. So this is tree. Here's shadow. Okay, the shadow of the tree, it tells me, is 20 feet. Now we have a person. Now I'm going to draw a really good person here because I'm really good at drawing people. All right, there's the person. Here's the person's shadow. Okay, so this is shadow. This is the person. Okay, how tall is the person? Well, it tells me the person is 6 feet tall. So this person is 6 feet. And this shadow length is 4.5 feet. That sets up my ratio. Okay, so I'm now going to do exactly what I'm saying, going from tree to person. Again, top to bottom. So I'm going tree versus person. Okay, height of the tree. Do I know it? Do you know the height of the tree? Told me the shadow was 20 feet, right? But it didn't tell me the height of the tree. So I'm going to let that be X. And I'm talking about height. The height of the tree, I don't know. It didn't tell me in the problem. So I'm letting the height of the tree be X. Does it tell me the height of the person in the problem? It says a 6 foot tall person. So yes, I do know the height of the person. They're 6 feet tall. Okay. And then what does the 20 and the 4.5 represent? Represent shadow. Okay, so this is shadow length. What's the shadow length of the tree? 20. What's the shadow length of the person? 4.5. Now I have just another ratio that I'm going to cross multiply and solve. You're going to do this a million times on this test. You're going to cross multiply and solve for X a million times on this test. All right, so I'm going to cross multiply. I've got 4.5X. Remember, you go top of the left to bottom of the right. And then bottom of the left to top of the right. 6 times 20 is 120. Okay? Can you see that? Sorry. Might be getting too close. Okay, so then I'm going to divide both sides by 4.5. This is where I'm going to need a calculator. 120 divided by 4.5.
26.66.
26.666. Devil worship forever, notice. 2/3 of the people. That's who Satan's after. All right, so anyway, there you go. 26.666. That's going to be your answer. Or 26 2/3. Okay, and that is the height of the tree. So I need to put that in feet. Okay, that tree is 26 2/3 feet tall, approximately, based upon that ratio of the shadow. All right, let's go to the next ones. Okay, this one we're going to have parallel lines. And how come that creates a similar figure? Well, remember, we have something called angle-angle similarity. If I can show that two angles are congruent, then I know the figures are congruent. Well, this angle and this angle have to be congruent because they're corresponding. These two angles have to be congruent to each other because they're corresponding. One's inside, one's outside the parallel lines. So therefore, the top triangle, just think about this, BCD, that's the top triangle, and the big triangle, CAE, are actually similar by angle-angle similarity. Okay, by angle-angle similarity. So therefore, we know these are equal anytime we're going to have a parallel line through a triangle. Now, that doesn't mean that they're exactly the same. Obviously, this one's smaller and this one's bigger. So they're not exactly the same, but they are creating a similar figure where we can set up a proportion and solve by cross-multiplying again. That's all we're going to do. So think about this. AE, I'm going to write that length in. That's 8. BD, I'm going to write that length in. That's 3. AE represents a length of what triangle? The big one or the small one? Well, that's the big triangle. So I'm going to write that on top. Well, actually, I should do small to big, like I've been doing. So it goes top to bottom. So let's do small to big. Okay, that's how I'm going to set up my equation. Again, if you'll write this out to the side before you start actually writing your ratios, you won't get the ratios wrong. There's a lot of numbers here. We know that AC from here to here is 12. Okay, it tells us that. Well, that represents big. So if I'll write small to big, I won't mess up. So small BD, being 3, over big corresponding side, which is the base, that's 8. Notice 3 and 8 are corresponding. That should equal, find BC. BC is the left side of the small triangle. So this is really left. This is base. So the bases were 3 and 8 from the small to the big. Base of small, 3. Base of big, 8. Left of small is going to be BC. I don't know that. That's what I'm looking for. Left of big hey, that's the 12 that they're giving me. Am I ready to cross multiply? Yes, I just cross multiply now. So 12 times 3 is 36. 8 times BC. Okay, I've got to get the BC by itself, so I'm going to divide by 8. Again, you might need a calculator for this. BC is going to be 36 divided by 8.
4.5.
4.5. And that's your length of BC. Does that make sense? Well, when I ask that question, does it make sense? Think about it. The small triangle compared to the big triangle, obviously these corresponding sides should be smaller than the big corresponding side. We knew that this side length had to be less than 12, and it had to have a ratio of about 3 to 8. Well, okay, that's 4.5 to 12. If you actually divided these on a calculator, do 3 divided by 8 on the calculator. So if you do 3 divided by 8 on a calculator, it's going to be 0.375. That should match exactly the left side, 4.5, divided by 12. You can do it on your calculator. 4.5 divided by 12 is 0.375. And you'll end up with exactly the same thing. That's an easy check to make sure you're doing the questions right. Okay, let's go down here. Sorry I smeared this when I did it, so I'm going to rewrite this so you can see it. So it says one picture is a 5 by 7. Another picture is an 8 by 11. Are these pics similar? And explain why or why not. Okay? Well, obviously a picture is rectangular, right? So 5 by 7, 5 here, 7 here. Okay? And we're saying, is that similar to a rectangle that is 8 by 11? So a lot like I did the division here to get that decimal, I want to do the division here to get the decimal. Again, think about this as length to width, okay? What's the length of the top triangle? 7. What's the length of the bottom triangle? 11. Okay, what's the width of the top, or rectangle? Did I say triangle? My bad. Rectangle. What's the width of the rectangle? 5. What's the width of the rectangle on the bottom? 8. All I got to do is see if these are equal to each other. Now I could do this on a calculator and divide those and divide these, see if the decimals are the same. I can also just cross multiply and see if those values are the same. What's 8 times 7? 56, I think, I hope. 8 times 7. And then 5 times 11 is 55. Those are close, but they're not exactly what? The same. So are these similar? No. Why? Because these were not equal. Now, if you wanted to, you don't have to cross multiply here. You could do 7 divided by 11, which is
0.636.
636. And I could do 5 divided by 8, which is, I think that's 0.6.
0.625.
Oh, 25. Again, those are close, but they're not exactly similar. So therefore, those would not be similar. Okay? So if you actually enlarged a 5 by 7 onto an 8 by 11 piece of paper, it actually wouldn't be exactly the same, but it's close. All right, let's do this one over here. We're going to do a dilation of a figure. So we're going to dilate it by 2/3. Every single point has to get multiplied by 2/3. Every x coordinate and every y coordinate for the dilation. So I'm just going to take 3, because this is -3 and 3, but it doesn't matter. What's 3 divided by 3? That's 1. What's 1 times 2? 2. So in other words, if you think about that, -3 times 2/3 equals, the 3's divide out, this is 1, -2. So I'm going to go to -2, and then I'm going to go to 2. So I'm going to go -2, 2. That's the dilation of that point. So I'm just taking the endpoints. Don't worry about all the side lengths and all that crap. Look at the endpoints, okay? That's going to give me -2, 2. All I did is times those points, the x and the y, by 2/3. Same thing's going to happen here. What's 6 times 2/3? If you need to, write it down. Divide those down. 3 goes into 6 twice. 2 times 2 is 4. So I'm going to go over 4. That's the x-coordinate. That's why I'm going over 4. 6 was the x-coordinate. So now this value, which is 4, is going to be my x value. Now, what's 2/3 of 3? Well, we already did that. 2/3 of 3 is going to give me up 2. So I'm going to go over 4 up 2. So this point is 4, 2. Okay, there's that point. The last point I have to do is 0, -9. Again, timesing 0 by 2/3 is still going to be 0. So I'm still going to be on that y-axis. But I've got to take -9 times 2/3. Just realize I've times everything by 2/3. 3 goes into 9 3 times. This is going to be -6. 0 didn't make any difference, so I'm just going to stay at 0 and go down 6. So there's 0, -6. Now usually I'm going to do this in a little different color. On your thing, you just mark those points and then put the connection thing on your Alex assignment. So you'll just mark the points and then connect it with a line segment. They'll have a little line segment tool that you can do that. Line segment here, line segment here. Now, it may ask you, name the pre-image and name the image, okay? And it may say, hey, this one is X, Y, Z, and this one, new one, I want you to call A, B, C, okay? If that's the case, and you're supposed to write a similarity statement, then that's what you would do. So you would say, my similarity statement would be X, Y, Z triangle is similar to, and then you have to think of the corresponding parts. So what corresponded to X? A. What corresponded to Y? B. And what corresponded to Z? C. Very simple to do. Okay? Next one. Here's the two figures. This is, again, it kind of smudged there. So this is the pre-image. And this is the image. And it asks, are they similar? What's the scale factor? And tell me the similarity statement. So we're going to do kind of similar to what we did up here, only we don't have to draw it. We'll start looking at these. What should happen? Again, pre-image to image, okay, you always want to start with the pre-image on top. So this means pre-image to image. Is that the way we did it? Yeah, that's the way we did it. Pre-image to image. So this is going to be pre-image to image on the bottom. So this is going to be 2 to 1, smallest side here, smallest side here. Then think of the next one, next smallest, 3 to 1.5. Then the next smallest, 4 to 2. This is going to be 2. What's that going to be? Do it on your calculator. 3 divided by 1.5. Guess what? It's 2. 4 divided by 2. Guess what? It's 2. If all of these are the same, what can I say? It's similar. That's all I had to do. Again, let me review that. I went small to small, small side to small side, medium side to medium side, large side to large side. Okay? What is the scale factor? Well, it's whatever this reduced value is that's the same on every one of them. It's 2 over 1. So the scale factor is 2 over 1. It's whatever the reduced value is on every one of these, which is what we have. Write a similarity statement. All right, now I got to kind of pay attention to how the letters are arranged. If I'm going to start with triangle ABC, don't just assume that it's similar to XYZ. A lot of people think that that's going to be the case. But if you look at the pictures, notice that the shortest side goes from A to B. So I'm looking for the shortest side here. As I look at that shortest side, it's 1. It's going to go from Z to X. So I have to write triangle Z to X. This shortest side, A to B. This shortest side, Z to X. Don't automatically write XYZ. Make sure your corresponding parts are correct. A corresponds to Z. B corresponds to X. C corresponds to Y. So C corresponds to Y. That's my similarity statement. Okay, last two. An actual car is 11 feet long, and the model of the car is 2 feet long. The model's door is 10 inches. What's the actual door length? Okay, so I want to go model to what? I want to go model to actual car. Or I can go actual car to model. It doesn't matter how you start. Just realize that that's what you're going to do. I'm going to go from model to actual. Again, you could go actual to model. You just have to write it out to the side to start with. So the model car length is 2 feet. I'm going to do something here. You tell me why I did it. What did I write? 24 inches. How did I get that out of 2 feet? Well, 2 feet is 24 inches. How come I'm converting everything to inches? Well, I noticed in the problem that the model door is being measured in inches, not feet. So I either have to convert the inches to feet, which would be a decimal. I'd do 10 divided by 12. Do I want to use decimals? I don't. So I'm not going to do 10 divided by 12. In other words, I want to use just bigger numbers. I can always make feet inches. I just got to times it by 12. So 2 times 12 is 24. So what would your actual car length be if I'm timesing it? Remember, I took 2 times 12. I've got to take 11 times 12. 11 times 12 is 132 inches. Okay, now everything's being measured in inches. The key on this problem is to make sure you convert to make sure everything's in the same values. I'll show you that you could have went the other way. Let's say I had wrote 2 to 11 equals, okay, and then here I had wrote 24 inches to 132 inches. Well, let's do this one. The model now is 10 because it's still being measured in inches. Okay. However, the actual car door length, I don't know. I'm just going to put an X there. Okay. Now notice here what I would do. If I was going to use feet, notice this is in feet, this is in feet. I'd have to change the inches to feet. I'd have to do on a calculator 10 divided by 12. 0.83. Repeating? Okay. So I'm going to do like 3 of those just to make sure I get enough as I do it. Over X. Both of these are actually going to give you the same answer, believe it or not. Because these are all being measured in feet. These are all being measured in inches. Again, I don't like using this repeating decimal. It creates kind of a mess. So I like to do it here. I like to make the units smaller, not bigger. But I'm going to cross multiply both and just show you that they both work. So on the top one, okay, I'm going to put that one right here. I'm going to put cross multiplying 24x equals 132 or 1,320. I'm just doing 132 times 10. I'm going to divide by 24, and x will be 55. And that is what? 55 what? Inches. Now pay attention to what it's asking for. Does it say how many inches is the car door or how many feet is the car door? If this wanted it in feet, I'd have to divide the 55 by what? 12. So 55 divided by 12 would be how many feet?
4.583333.
Okay, and that would be the number of feet that the car door is. So your car door length is about 4.5